इस शहर को ये क्या हुआ, कहीं राख है, कहीं धुआं धुआं. I'm going to discuss something really important today. This video is not only for those who smoke but also for people like me. अभी तक आपको लगता होगा that only smokers are at the risk of lung cancer, but what if I tell you that if you remain indoors for long periods of time, be it your workplace or home, and that too without following appropriate safety measures, you too might be at the risk of lung cancer. Now don't say, oh come on, because it's radon. Radon is a naturally occurring radioactive gas which may be found in high concentrations in indoor environments such as homes and workplaces, and it is one of the leading causes of lung cancer. Out of all the known isotopes of radon, radon 222 is the most stable one with a half-life of 3.8 days. Radon has no color, smell or taste, and it is found in natural radioactive decay of uranium, which is found in all rocks and soils. Now radon escapes from the ground into the air where it decays and produces further radioactive particles. So as we breathe, these particles can deposit on the cells lining the airway where they can damage the DNA and can potentially cause lung cancer. So indoors radon पहुंचता कैसे है? Radon enters the buildings through cracks in floors or at floor wall junctions, gaps around pipes or cables, small pores in hollow block walls, cavity walls, sumps or drains. In many countries, drinking water is obtained from groundwater sources such as springs, wells and boreholes. These sources of water normally have a higher concentration of radon as compared to surface water from reservoirs, rivers or lakes. Now this means that radon can also be found in water. Radon levels may be high in water treatment facilities and spa facilities using natural water. Again, this radon dissolved in drinking water is released into the indoor air, but normally a higher radon dose is received from inhaling radon as compared to its ingestion. रेडॉन को ब्रीथ करके अंदर ले जाने से आपको ज़्यादा खतरा है एज कम्पेयर टू कि रेडॉन आप खाने के थ्रू या पीने के थ्रू अंदर लेके जा रहे हैं. Radon levels are usually higher in basements, cellars and living places in contact with ground. However, high concentration of radon can also be found above the ground level. Radon concentration is higher indoors in areas with minimal ventilation. जहाँ ventilation बहुत कम हो वहाँ उसके concentrate होने का, जमा होने का खतरा ज़्यादा बढ़ जाता है. And the highest levels are found in places such as mines, caves and water treatment facilities. It is estimated that radon causes between 3 to 14% of all lung cancers in a country, depending upon the national average radon level and smoking prevalence. An increased rate of lung cancer was first seen in uranium miners exposed to very high concentrations of radon. However, studies have confirmed that even low concentrations of radon, such as those found in residential settings, they also pose health risks and contribute to the occurrence of lung cancers worldwide. In buildings such as homes, schools and offices, radon levels can substantially vary from 10 to more than 10,000 becquerel per meter cube. However, outdoors, बाहर जो radon का level है, it dilutes to very low concentrations and it's generally not a problem. Outdoors, the average radon level can be between 5 to 15 becquerel per meter cube. So indoors, the danger of radon levels is more and it is generally considered dangerous to exceed 300 becquerel per meter cube. इन सब के ऊपर अगर आप स्मोक करते हैं तो दोनों की मंजिल, रेडॉन की और स्मोक करने वालों की मंजिल एक हो जाती है. तो दिस लीड्स टू सिनर्जिस्टिक इफेक्ट्स. तो लंग कैंसर होने का खतरा और बढ़ जाता है. रेडॉन इज मोर लाइकली टू कॉज कैंसर इन पीपल हु स्मोक. तो नॉन स्मोकर्स के कंपैरेटिवली स्मोकर्स को 25 गुना ज़्यादा खतरा है रेडॉन से. रिस्क ऑफ लंग कैंसर इंक्रीजेस बाय अबाउट 16% per 100 becquerel per meter cube increase in long time average radon concentration. Now this dose response relationship is assumed to be linear. That is, the risk of lung cancer increases proportionally with increase in radon exposure. So you now know that radon is dangerous, invisible and radioactive, and the only way to know how much radon is in your home or workplace is to test it. How? Use radiation detectors. कैसे? Demo देते हैं. So if you are a physics student, you must be knowing about electron and holes, and with that we have a fully discharged capacitor with electric field lines cancelling one another. So this fully discharged capacitor is now connected to the ionization chamber. It is a gas field detector which is used to detect radiations. Now this ionization chamber initially is having only neutral gas atoms or molecules, so it is acting as an open circuit. There are no charges. We now introduce a voltage source with voltage V0 and connect it to the ionization chamber and this fully discharged capacitor. So this voltage source V0 will enable this fully discharged capacitor to now become fully charged, and the electric field lines will gradually be directed or oriented in one direction only at the end. In the absence of any ionizing radiations and if there is no leakage across this capacitor, this situation will prevail indefinitely. क्योंकि इस capacitor का कोई discharge ही नहीं हो रहा, तो जो initial condition है, जो initial charge stored within this capacitor will be CV0, where V0 is the initial value of the voltage जो कि voltage source ने provide करवाई थी. Now next thing is exposure to radiation. Now neutral gas or atoms enclosed within this ionization chamber, if they are exposed to some sort of ionizing radiation, what will happen? Ionization of this neutral gas atoms will take place. So this will lead to an emission of electron and cation. Cation भी एक positively charged entity है, मतलब उस neutral gas atom में से electron निकाल के बाकी जो positive residue बना, that is a cation, and cation is different from holes. होल्स एक इलेक्ट्रॉन वैकेंसी है इन एन एटम. फिजिकल एंटिटी कोई नहीं है, ये कोई पार्टिकल नहीं है होल, एंड दिस इलेक्ट्रॉन एंड द कैटायन इज व्हाट कॉन्स्टिट्यूट्स एन आयन पेयर. Sorry, but I need to raise my voice. There is a construction work going on and some aunties are disturbing me. Now next thing is that this gas enclosed within this ionization chamber is exposed to some sort of radiation, and as a result of this there will be an emission of an electron and the cation of the atom, of the neutral gas atom. Now this capacitor, this fully charged capacitor is acting like a battery. It has two plates. One of the plates is entirely positively charged and the other is negatively charged. So what happens is that electron will move towards the positively charged plate. So this positively charged plate will act as an anode. So what happens at anode is that this electron will occupy a hole. Also we have a cation as well. Now the negatively charged plate of the capacitor will act as a cathode, and what happens at cathode is that this positively charged ion, which is the cation of the gas, that will pull out an electron, from this cathode and will itself become a neutral gas atom or molecule again, and this pulling out of this electron from this negatively charged plate will create a hole. Hole is simply an electron vacancy. What happens as a result of this is that the electric field line will be directed anti-parallel, and this will lead to the decrease in the charge, the voltage and electric field lines within this capacitor. So at cathode, the cation pulls out an electron and becomes a neutral gas atom or molecule again. We now see that the charge stored within this capacitor is now reduced by an amount, say Q1, and this will be equal to CV1, where V1 is the new reduced voltage across this capacitor. So if we subtract the two equations, that is the case of fully charged capacitor with the present case, you will get this result. The measurement of voltage drop across this capacitor will indicate the total charge that was created by the radiation. तो अगर आपको इंसिडेंट रेडिएशन ने क्या चार्ज डिपॉजिट किया विद इन द आयनाइजेशन चेंबर कैलकुलेट करना है, दैट इज इक्वल टू डेल्टा क्यू. Initially charge was 0. So this measurement of potential drop across this capacitor is a direct measure of total charge that was deposited due to the ionizing radiations. If you divide this equation by a time interval delta t, you can calculate the integrated ionization current over the period of measurement. But what's the connection? जो हम पढ़ रहे हैं उसके साथ ये जो हमने डिटेल डिस्कस करी है उसका क्या लेना देना? Now one thing that I will be now doing is that we will replace this capacitor with something called an electret. So measuring the drop in surface voltage across an element known as electret will serve the same purpose as that of the capacitor in the earlier case. You have heard about magnets. Now what is this electret? Electrets, like magnets, are dipoles. Unlike magnets that produce magnetic field, electrets produce electric field. Electret is like an electric magnet. It is able to generate a permanent electric field. It can be called an electrostatic magnet. Electret was first described by Oliver Heaviside in 1885. Electret is a sample of dielectric material, commonly Teflon, which carries a quasi-permanent charge. Electric charge. The disc of this material is 1 cm in diameter and 1 mm thick. Dielectric is an insulating material or a very poor conductor of electric current. When dielectrics are placed in electric field, practically no current flows through them because unlike metals, they have no loosely bound or free electron that may drift through the material. Instead, electric polarization occurs. The positive charges are displaced minutely in the direction of the field and the negative charges in the direction opposite to that of the field. So the electret disc is fabricated by heating in the presence of electric field and then cooling. Why? In order to freeze the electric dipoles in place. As a result of this, the voltage of about 1000 volts may appear across the two surfaces of this electret. So in the previous case, the fully discharged capacitor charged itself by the use of an external voltage, and this resulted in the electric field lines to be developed and aligned in one direction only. This entire job is now handled by only one entity, which is electret, which is having its own electric field. So as demonstrated in the earlier case, let us assume that before any sort of radiation exposure, the voltage across the two surfaces of the electret is V0. So again you have an ionization chamber in which you have entry holes through which this radon can diffuse into this chamber. Next, this electret disc is placed at one end of the chamber. So the chamber walls and they are conducting. So if the negative end is placed, the entire wall of the chamber will be now negatively charged. The upper surface of the disc will be positively charged, and as a result of this, the electric field lines will be oriented like this, from positive to negative charge. So you know that radon is a radioactive gas, and as it enters this ionization chamber, what will happen? It will decay. It will further decay, leading to emissions of alpha or beta particles, and it is this alpha or beta particle which will further ionize the neutral gas atoms present in this ionization chamber. Now what will happen? Again, the ionization will take place, which will result in the emission of an electron and a cation, and their gradual collection towards their respective electrodes will lead to a drop in the voltage across this electret, and let us say that it is V1. So as discussed earlier, this measurement of voltage of the electret before and after exposure can be calibrated in terms of total ionization charge produced within the chamber. Apart from this, electret ionization chambers are expected to find newer applications in areas such as space missions, wherein long-term monitoring of low levels of radiation is required. Continuous research in this field may lead to more compact and more cost-effective designs in future. So as our need to monitor and understand radiation exposure continues to increase from healthcare to space missions, the importance and utility of electret ionization chambers can only be expected to increase. Electrets serve as basis of EPERM, Electret Passive Environmental Radon Monitor. EPERM is widely used to measure the ionization caused by the alpha particles, which is produced in the decay of radon which diffuses into the chamber. Now I used a term passive. What is the difference between an active and a passive detector? Passive detectors do not need an external power supply in order to operate. So you saw that for the case of electric, which was having its own voltage supply, its own electric field, and you did not connect any external power supply to that. Also for the use of capacitor, you saw that the external voltage source was initially used only to charge the capacitor and later on it was disconnected. So passive detectors do not require any external voltage source. They are also comparatively smaller and lightweight as compared to active detectors. Active detectors like your ionization chambers, all the gas-filled radiation detectors, they have their well-equipped display, electronic display and meter, and they are used to take real-time readings. They provide absorbed dose and related information in real time. On the other hand, passive detectors usually operate in cumulative mode. Exposure to the radiation of a passive detector causes accumulation of the signal, and this signal is stored in the detector. So the information from a passive detector can be extracted at a later time. So we conclude this video with some preventive measures which one can take in order to reduce the risk of radon exposure. Radon prevention should be considered when new structures are built, particularly in radon prone areas. In many countries, the inclusion of protective measures in new buildings are included in the building codes. However, in the existing buildings, some of the common ways to reduce radon levels can be: avoid making such lifestyle changes like converting your basement into a bedroom. Increase underfloor ventilation, installing a radon sump system in the basement or under a solid floor. Avoid the passage of radon from the basement into the living spaces. Sealing floors and walls. Improving the ventilation of the building, especially in the context of energy conservation. Passive system of radon mitigation can decrease indoor radon levels by up to 50% or even more. When radon ventilation fans are added, levels can be reduced even further. Radon concentration in drinking water can be reduced by aeration or by using granular activated carbon filters. Apart from this, World Health Organization provides policy options for reducing health risks from residential radon exposure through providing information on levels of radon indoors and associated health risks, implementing a national radon program aimed at reducing both the overall population risk and the individual risk for people living with high radon concentrations, establishing a national annual average residential radon concentration reference level of 100 becquerel per meter cube, but if this level cannot be reached under the prevailing country specific conditions, the reference level should not exceed 300 becquerel per meter cube. Developing radon measurement protocols to help ensure quality and consistency in radon testing, implementing radon prevention in building codes to reduce radon levels in buildings under construction, and radon programs to ensure that the levels are below national reference levels, promoting education for building professionals and providing financial support to remove radon from existing buildings, and considering the inclusion of radon as a risk factor in national strategies related to cancer control, tobacco control, indoor air quality and energy conservation. WHO promotes the implementation of these radon standards which ultimately support the 2023 Agenda for Sustainable Development Goals and Target 3.4 on non-communicable diseases. So with this we wind up today's video, and thank you so much for watching till the very end. I appreciate your patience, and do share this information as much as possible, and do not forget to take really good care of yourselves.